Those drones have a tiny camera right here and a range sensor, just a sensor to detect the range. And by that drone knows how to stay still. So the idea is very simple. It's like a computer mouse. If it moves a little bit, then the camera detects there's like optical flow. There's a movement in terms of the pixel. Then it goes back. Let me demonstrate that in the phone again. So now I'm starting a different app, which is a very one of my favorite apps ever, and it's called BoofCV. This BoofCV is an amazing app. It's actually a library. It's a mathematical library in computer vision that allows us to demonstrate or to take part, to use the phone camera and the phone processor and screen in order to understand computer graphic algorithms. So let's start with that. I'm holding the tracking, and what I'm going to do is ask the phone to track points. I'm moving my phone, and you see those points being tracked. Let's demonstrate that again. Let's have it in a crazy manner. So there's a lot of feature points. This is the little purple thing. And when I move the phone, I see this vector, this reddish vector. And whenever I do that in a sphere kind, and so you see the sphere, whenever I do it in terms of angular, then all the vectors are more or less the same. And if I do it with like a movement, a real movement, then things close enough, the change is really big. But things that are far away, the change is relatively minor. This is because this is the way that whenever we I don't know, very close to the ground, things seems to us as moving very fast, although we're just, I don't know, skateboarding. But when we take an airplane, not COVID-19 now, but assuming on regular days when you fly on an airplane and you look at the window shield, then you see we hardly move. Obviously you move, but your distance is so significant, then you only detect little movement. This is actually exactly what the optical flow here is doing. You have an optical flow or a camera, a very, very simple camera, that counts the number of pixels you've been moving. I don't know, in that manner and well, let's say it in an X manner and a Y manner. Obviously it's the other way around, but who cares? And if you know your distance to your prospective plane or to the ground, then you can interpolate the number of pixels you've been moving forwards towards an actual velocity or an actual distance.